Hello, everyone. Today we're diving into a fascinating and critical topic: how specific brain areas develop during adolescence, the factors influencing this process, and how substances like cocaine interact with the nervous system to influence addiction. Let's explore these complex interactions and their broader impacts on our health.
During adolescence, the brain undergoes significant changes. Two critical areas involved are the prefrontal cortex and the limbic system. The prefrontal cortex is responsible for decision making and impulse control and experiences increased synaptic pruning and myelination, making it more efficient. On the other hand, the limbic system is associated with emotions and rewards and is highly active. The heightened activity makes adolescents more sensitive to rewards and risks. Genetics, environment, and exposure to substances like cocaine can influence these developmental processes.
Addiction is a chronic, relapsing condition characterized by compulsive drug seeking behavior despite adverse consequences. It disrupts the brain's reward system, particularly in the prefrontal cortex and the nucleus accumbens, which is the neural interface between motivation and interaction, through overstimulation of dopamine pathways. Dopamine is a neurotransmitter that plays a central role in reward and pleasure. Addiction hijacks the system, reinforcing behaviors that prioritize drug use over natural rewards.
Cocaine is a powerfully addictive stimulant derived from coca leaves, primarily grown in Bolivia, Peru, and Colombia. Once processed, it's available in different forms, like powder, solid rock, or liquid. Cocaine can be snorted, smoked, injected, swallowed, or chewed. The method of intake affects how quickly it reaches the brain and the intensity of its effects. For instance, smoking delivers a rapid, intense euphoric rush, while snorting causes a lower, less intense effect. Cocaine works by blocking dopamine transporters, preventing dopamine from being reuptaked. This leads to excessive stimulation of dopamine receptors, causing euphoric and heightened energy. However, with repeated use, the brain reduces its natural dopamine production, leading to dependency and diminished response to natural rewards.
Cocaine's overstimulation of the dopamine reward pathway triggers neuroplastic changes in the brain. The prefrontal cortex loses its ability to exert control over impulses, reinforcing drug-seeking behavior. Long-term use alters dendritic spine density, changes synaptic connections, and causes maladaptive plasticity, making it harder to respond to natural rewards. This rewiring impairs decision-making and emotional regulation, increasing the risk of mental health disorders like anxiety and depression.
Cocaine doesn't just affect the brain, its impact is systemic. It affects the cardiovascular system as cocaine increases heart rate, blood pressure, raising the risk of heart attack and stroke. It also affects the respiratory system, where a high dosage can cause respiratory distress or failure. It also affects the endocrine system as it disrupts stress hormone levels and can cause anxiety and depression. It also disrupts liver function. When mixed with alcohol, cocaine forms cocaethylene, a toxic compound that strains the heart and liver.
Withdrawal from cocaine often leads to agitation, fatigue, depression, and vivid dreams. Recovery involves acknowledging the addiction, changing habits, and seeking support. Activities that boost dopamine naturally, such as exercise and positive social interactions, can aid in rebuilding the brain's reward system.
Adolescence is a critical period of brain development, and exposure to substances like cocaine can profoundly alter this process. By understanding how addiction develops and affects the nervous system, we can take steps to prevent and address its consequences. Thank you for listening.